This right here is a Raspberry Pi. It's a tiny little computer with an exposed board that I can dunk into water, and it will continue to play the video that is on screen right here using this HDMI cable, and it's also getting power using this USB cable. And this despite the computer being completely submerged. This footage will likely make you feel very uneasy because you might remember either from your physics classes or from just playing Pokemon, I guess, that water and electricity aren't usually a great match. And yet, this computer works just fine. Engineers have gotten really creative by now, inventing many technologies for making electronics water resistant. From nano-coatings like the one applied here to advanced glues and even crazy things like filling watches with oil, the world of water resistance has gotten pretty sci-fi. So in this video, let's talk about how these different technologies work, why different types of protection are applied to different types of devices, and why you might still not want to trust any of them unless you must. This video is sponsored by Nebula. Most of our everyday electronics dislike water for two main reasons: conductivity and corrosion. Obviously, on a device you don't want to link parts electronically randomly, as that might short your components or cause damage in other ways. And if water was a great conductor, then dunking your exposed electronics into it would create all manner of unwanted connections. But perhaps surprisingly, water itself is not conductive at all, and I can prove this to you because I bought a bottle of distilled water on Amazon. This should consist almost entirely of H2O molecules, and I can show you that this doesn't actually conduct electricity. Now that this is filled, I can take my phone. This is an old phone that has no waterproofing, and I've also on purpose taken out the SIM tray, and I can dunk this into the water, and it should continue working just fine. There's water inside the phone. I've dunked it completely. It has entered the phone. You can see it kind of dripping out of it, and yet the phone works just fine. H2O molecules don't have free-flowing electrons that they want to get rid of, so this water is not actually conductive on its own, and nothing much happens. Instead, the problem with water in the real world is not the water, but the fact that they actually contain things like salts and minerals like iron and magnesium, and those do have free-flowing electrons, and therefore they actually turn the water conductive. And that conductivity might short either a local component, such as a button that would stop that component from working, or depending on where the water landed on your device, it might short a critical component that might actually kill your device altogether. And meanwhile, corrosion is our second big problem, which typically sneaks up on you over time. In this excellent video from iFixit, you can see what happens to a phone board sitting in slightly salty water for even just 1 hour. This means that even if you dried out your phone with rice or whatever after you fished it out of the water, the damage would already be done, leaving behind traces that corrode your solder joints, oxidize your components, and make your circuits weaker in general. Sharam Mokhtari from iFixit told us that corrosion damage often goes unnoticed and the device just keeps on working for a while. But then days, weeks, maybe months later, when you, for example, dropped your phone, a corroded contact might actually break or come loose, and it could break your entire device. And when you took that to a repair technician, you'd have the following really awkward conversation.
And the person will say, well, that's nonsense. All I did was drop the phone. I didn't drop it in the toilet, I didn't drop it in the bathroom. I just dropped it. Well, the contacts were corroded and they were brittle enough that when you dropped it, that connection was lost. So it was water damage, but try convincing the consumer, because the consumer believes this device was waterproof because that's what manufacturers told them.
Yeah, so that's corrosion. It sneaks up on you over time. And then there's also a third problem for things like these that actually have to go deep underwater, and that is pressure. Stuff like action cameras, dive computers, and more all have to deal with a whole lot of pressure. The deeper you go, the higher the pressure, as all that water is weighing down on you. When you're at the surface, you're at 1 atm of pressure, meaning that you only have the atmosphere of the Earth weighing you down. Going down by 10 meters or 33 feet doubles that pressure, and every 10 meters from there adds another atm. And all that pressure can physically crush your devices and its sensitive components. Okay, so those are our three main issues. Now let's see what some of the solutions look like on different classes of devices. On the most basic level, most older phones don't actually have any official protection, but even here you typically have some rubber or silicone rings around the components that are exposed. On this Lumia 950, there's one around the camera ring and one around the speaker array, for example, which might keep some light splashes out. That said, this is a removable back with a lot of flexing, and so all the seals are far from perfect and there's no claimed water resistance as a result. Then on the next level, we have something like the Fairphone 5. This is a modular phone with a completely removable back and components that you can take apart yourself, and yet still there is an IP55 rating. The first number here describes protection from solid particles such as dust, while the second one focuses on water, and 5 means that this phone is rated to survive water jets, meaning basically splashes of water and rain, but not an accidental dunk into your toilet, for example. There are no visible physical protections against water here, and Fairphone has instead confirmed to us that they have achieved the water resistance by applying nano-coating on both the interior as well as the exterior of the device. Nano-coatings are also the star of the show on this Raspberry Pi that I showed you up front, which I got sent over from one of the nano-coating specialists called HZO. And meanwhile, the YouTube channel Phone Repair Guru has figured out that nano-coatings are also used in the case of the brand new Galaxy Buds 3, for example. This allows the internals to slide out for better repairability instead of being heavily glued together, while the case still maintains a pretty respectable IP57 rating. The basic idea is that nano-coatings make a lot of sense if a device can't be properly sealed completely from the outside, or maybe as a secondary layer of protection. HZO, the company that sent us the Raspberry Pi, was also nice enough to explain their process to us, which works with a material called perylene, which is a polymer. The components that are to be coated are placed in a rack inside a vacuum chamber. The perylene gets heated up, which turns it into a vapor, and then this gets injected into the chamber, where it is carefully cooled down again so it condenses all over the components. This process is called chemical vapor deposition, and the good thing about it is that it creates a uniform layer that is really easy to control. Depending on the amount of time in the coating chamber, HZO can control how thick the layer becomes, which they typically aim to be just microns thick. Perylene is of course inert and not conductive, so it will act as a barrier between the device and the water, corrosion, etc. on the outside. Of course, some parts, like the connectors for example, we actually want to remain conductive, so those are masked out with basically precisely applied stickers, and you can see on our board that for the sake of this demo, there's some heavy-duty glue around the connectors that can't be coated. Still, the rest of the components get properly sealed. HZO's approach is one of many, and alternatives include using acrylics and silicone, but those can often be thick and interfere with thermal management and wireless signals, so thin materials are generally preferred. Now, nano-coatings aren't even all that expensive, with HZO telling us that their solution typically costs a few dollars per device, but manufacturers have only really embraced this technology en masse in products that can't be properly sealed. Almost all regular electronics, though, are typically built so that they keep water out in the first place. And in the old days, this meant literally sealing up every port from the outside. This is the Motorola Defy, which to my knowledge is the first phone with a proper IP67 rating, and as you can see, everything here is locked behind physical latches, including the battery, the USB port, and the audio jack. There is a physical locking mechanism to the battery compartment, and also a silicon gasket around the whole battery. Now, instead of this old-school approach, today almost all mainstream electronic brands instead just seal up your device as much as possible from the inside using primarily glue and silicon gaskets. And surprisingly, this includes even some of Samsung's foldables, which actually keep water out using heavy glue, then these silicone strips around the hinges, and also some water-repellent lubricant around the hinge. Pretty wild. These solutions are likely preferred over nano-coating because on the one hand they're easier and cheaper to mass manufacture, and on the other hand they also create a sort of sealed chamber which helps keep out the dust as well as the water, so there's two birds with one stone. A couple of years ago I thought that manufacturers would actually start doing both, so basically glue for the first line of defense and then nano-coating on the inside as a backup, but instead a simple seal seems to have won in most cases. Also, at this point, it's important to point out that even if your phone has a water resistance rating, that rating only applies on the day that you get it. With time, the adhesives weaken, the coatings get scratched, you drop your phone creating tiny fractures, etc. And very often, months or maybe years later, your device might not actually be water resistant anymore. Almost no manufacturer actually covers water damage under warranty, even for IP certified devices. So in general, my strong recommendation is to trust your stated water resistance only if you must. Anyway, moving on to more challenging products, we get to things like action cameras. These are often rated to survive up to 10 meters underwater, which, if you remember, means 2 atmospheres of pressure. But beside that, they're also expected to survive water hitting them with big force, such as those coming from waves, and they're expected to survive things like salt water and chlorine too, which are significantly more corrosive than tap water. The first layer of protection on these devices comes from their ports almost always getting fully sealed, like you can see here. They're strong physical latches and much thicker silicone rings than usual. You can see that the metal latch here is a tiny bit rusty, which means that the water actually got that far when I was diving with it, but not further, which is the point. Now, I won't pick my own cameras apart because I still want to use them, but friend of the channel Strange Parts has done so with his Insta360, and he has shown that these things are of course covered in massive amounts of glue on the inside and also have seriously huge silicone gaskets all around, which makes sense. But beside that, these devices still have one big remaining challenge, which is their speakers and their microphones. These have to sit behind openings so that they don't sound muffled, and then their components also need to vibrate in air for them to work, which is really tricky. And Insta360 tells me that their solution is to use breathable, waterproof membranes on their openings, and if you've seen high-end sports textiles such as Gore-Tex, this works with the same principle. You basically use a flexible material to cover the holes, and that has pores with just the right size so that air molecules can pass them when on land, but water won't be able to squeeze in while you're diving, for example. That's pretty neat, but even these devices are only rated until 10 meters because at that point the breathable waterproof membranes might actually burst, and Insta360 also tells me that the buttons might actually be pressed in and might not be able to pop out on their own again underwater. Now, my dive computer here has buttons as well, and I've used those just fine at like 40 meters, so clearly just using different materials can mitigate this, but every safety feature is a trade-off, and most action camera companies have instead opted for waterproof cases for any adventures that go past 10 meters. And in these cases, a complete seal is created using heavy-duty silicone rings and clamps so that the cases can typically be rated for 50 to 60 meters. Okay, talking of dive computers, the ones made for recreational dives for normal humans like me typically come completely sealed with no exposed ports, microphones, or anything. The battery is accessible through this big screw cap, which not only has a chunky silicone gasket, but is also lubricated with silicone just in case, and this compartment is completely physically separated from the rest of the device, so if water somehow got in, the device itself would probably still survive. And the rest of the device is completely sealed with the only opening being these screws, which have multiple silicone rings for extra protection. Which finally takes us to the ultimate crazy product, deep sea watches from the likes of Rolex. There are some watches that have gone all the way down to the Mariana Trench, the deepest point of the ocean at 11,000 meters, and at thousands of meters, of course, pressure becomes the biggest challenge. The most visibly obvious adaptation that you can see on most of these watches is that the construction becomes way more robust and that the surfaces all become arched. In fact, the original Rolex Deep Sea Challenge from 1960, which was the first watch to go that deep, was almost a perfect sphere. The German brand Sinn has made the very clever alternative of filling the entire case interior of the watch, including the movement, with oil, and because liquids are much harder to compress than air, this means that the risk of caving in is much smaller, while the watch can also keep a much lower profile. But perhaps the coolest thing is the helium or gas escape valve that you'll find in Rolex watches, for example. These are only really useful for so-called saturation divers that go hundreds of meters deep to do stuff like fixing the oil rigs and underwater cables, and because coming up from that deep would take forever, these divers often live underwater and in pressurized chambers for weeks. These chambers are filled in part with helium gas, whose atoms are so small that they slowly seep into the inside of the watch, even through the tightest seals, and there they build up with time. And then, as the divers come up at the end of the dive, the gases might expand and the crystal could pop off. And to stop that from happening, the helium escape valve was invented that lets out the gas little by little. Now, fun fact, Rolex's second most ambitious dive watch, the Deep Sea, is rated for depths of 12,800 feet or 3,900 meters. That's an oddly specific number, right? Except the wreck of the Titanic is sitting just barely shallower than that at 12,500 feet or 3,800 meters. This watch is specifically made so that it would survive going down to the wreck of the Titanic in a way that the now infamous Titan submersible was not. Now, the Rolex Deep Sea is actually a watch that you as a layperson could at least theoretically buy if you had $20,000 to $60,000 in your bank account for a watch, that is. But it's still pretty crazy that you can buy a watch that can go as deep as the Titanic. This wreck in particular has fascinated people more than anything else at the bottom of the sea ever since it was sunk, and there's a whole industry dedicated to exploring it and even to bringing up parts of the wreck piece by piece to be displayed at exhibits across the world. The raising of the Titanic is documented in incredible detail with beautiful 3D animations, historical footage, and great storytelling in one of the newest Nebula original documentaries by one of my favorite content creators called Neo. If you care about deep sea exploration at all, you will love this episode, and Neo's whole Nebula original documentary series called Underexposure is full of fantastic episodes like this. Nebula is a video streaming service built and owned by educational creators like Neo, Mustard, Real Engineering, Polymatter, and of course me as well, and it allows for two pretty magical things. First, subscriptions like you actually finance a lot of our work, especially our most ambitious projects. And second, Nebula allows you to get even more content from the creators that you like, of course without ads and distractions, and often even stuff that is exclusive to the platform or at least appears there earlier. I, for example, have just started to do a little Q&A session at the end of every Nebula video on both of my channels. Signing up using my link in the description will also get you an extra discount, as my link brings the cost down to just $30 a year. Mind you, that is for a full year and not a month, and if you don't like ongoing subscriptions at all, you can instead also opt for a lifetime membership. So check it out, be sure to use my link go.nebula.tv/TechAltar for the discount, and I'll see you in the next video.